Often when we're working with algebraic expressions, it's useful to rewrite an expression that was given to us in another form that is equivalent. That's what we're going to focus on in this video. We want to write each of these expressions in mx form. And what that means is that we want our x to be all by itself, but being multiplied by some coefficient. Now the reason I use mx form is because this is usually useful when we're working with linear equations and we're trying to rewrite linear equations in mx plus b form. So I use the mx just so that we're familiar that usually we're going to do this when we're looking for the slope of a line, but it can also be used in other instances, such as when we're simply solving equations. Let's take a look at this first example. We want to rewrite 4x over 5 so that x is alone outside of the fraction and that it has just a coefficient. The logic that we're going to use, the logic behind this, is as follows. When we multiply fractions, here's what we get. We take, if I write a over b times c over d, and instead of using a c here, I'm going to go ahead and just change that to an x. Alright. If we were to multiply these fractions, we'd use the rule when multiplying fractions, multiply straight across, or when multiplying fractions, multiply numerator by numerator and denominator by denominator. So this would give me a times x over b times d. Alright, now what we can notice here is that this a times x actually came from multiplying a by x. Let's simplify this a little bit so that we can kind of work more directly backwards here, because what we want is not necessarily x over d, we just want x. So let's take another example here. Let's take a over b times x, because this is an expression written in the form that we want. So let's see what happens when we undo what we want and go to an expression that's going to look something like this. Here we would write every expression as a fraction by putting it over 1. And now we multiply straight across. A times x over b. Take a look at this. A times x over b. It looks exactly like 4 times x over 5. Like where my 4 would be an A and my 5 would be a B. How can we go backwards? This expression came from multiplying a over b by x. In other words, this numerator came from multiplying the numerators here. So if I want to go backwards, I can think, well, all I did was multiplied this part of the fraction, this part of the numerator, by an x. And if I take that x and move it outside of this fraction, say here, then I will have an equivalent expression. This is the idea that we will be employing here. Let's take a look at how we can put this to use here. I want to rewrite this without changing its form so that x has a coefficient. So I'm going to have some fraction out front here times x. So what I'm going to do is I'm going to set up that exact form here. Something times x. And this is a fraction bar here. So this numerator came from multiplying something by x. What do I have to multiply x by to get 4x? The answer there is 4. 4 times x would give me 4x. So if I put a 4 in this numerator, I wouldn't change the value. In order to keep the denominator, we need that 5 still to be in the denominator. So this is 4/5 times x. Now this is written in mx form, where 4/5 is the coefficient. 4/5 is the m. That's the coefficient of x. So this is how we can do that. Now you can always check it by multiplying and making sure that you get what you should get. So I could rewrite this 4/5 times x and write everything as a fraction by putting it over 1. 4 times x is 4x, and 5 times 1 is 5. Sure enough, I got the same thing that I started with. Once you get the hang of this process, it's really quite simple. All you're doing is taking an x out of the numerator and multiplying it by whatever is left of the fraction. Let's consider the second example. The x again is in the numerator, so all I have to do is take it outside of the fraction and put it in its own individual numerator. These are all factors, and I just take these factors and leave them in the original numerator, 2ab, and then I keep the denominator. This is 2ab over 3 times x. Now x has a coefficient. Let's consider the next example. This one is a little bit more complicated, but only in the way that it looks, because the x is not at the end of the expression in the numerator, it's somewhere in the middle. However, we can use the commutative property of multiplication, which allows us to change the order of the factors. So what I'm going to do is I'm going to employ that commutative property, and I'm going to take the x and put it at the end. So I'm going to keep this -3 factor in front, and I'm going to take this z factor and switch it with the x. So it's going to be -3z times x all over 7. Now I can take this x factor and bring it outside of the fraction. -3z all over 7 times x. Now m is -3z over 7, and it's being multiplied by x. This is an mx form. Now let's take a look at this last example, x over 5. I know I want to write this so that there's some coefficient times x, but here x is the only thing in the numerator. So if I were to think like I introduced the lesson, as though I'm undoing the multiplication of fractions, what would I have to multiply x by to get x? I would multiply x by 1 to get x. So this is just 1x over, and we keep the denominator 5. Another way you could think of this if you wanted to is you could give this x its coefficient. The coefficient of just x is 1. And if this helps you see exactly what needs to be going on here, keep the 1 in the fraction, pull the x out. That can also be another way that could be helpful for seeing this. Now, we can also check this one, kind of like we did with the first one, by multiplying it back together. So let's multiply 1. Actually, first off, we need to rewrite this so that x has a denominator. So this is going to be 1 over 5 times x over 1, and multiply straight across. 1 times x is x, and 5 times 1 is 5. Sure enough, we got the same thing we started with, so we didn't change the value. So this is the proper way to rewrite this in mx form, so that x has a coefficient.